guys, welcome back for this part. So as we have already studied work, energy, power, now what is the time? The time is to apply those concepts in over here in solving previous year JEE questions. So we have collected some important questions in from the previous year paper. So this is what we have to solve. Now let's look at how we can apply those concepts in solving previous year JEE questions. Now guys, previous year questions of JEE. Now let's look at the question number 1. A particle of mass small m is moving in a circular path of constant radius r such that its centripetal acceleration AC is varying with time as AC is equals to, so let's write it as AC is equals to k square r t square, where k is a constant and the power delivered to the particle by the force acting on it. So as we have studied about this thing that the centripetal force, the power delivered by the centripetal force will be 0. So therefore, we have to check it out that whether there is any acceleration along tangent or not. If not, then it will be 0. If it is, then power will be delivered by that acceleration. So what we can say that power is equals to force tangential if it is so dot V. So therefore we have to check it out that whether there is a tangential force or not. So what we can say that acceleration c is equals to k square r t square, and we know that acceleration is equals to speed divided by radius, speed square divided by radius as v square by r. So this as equals to k square r t square. So v square will be equals to k square r square t square, and hence what we can write, v will comes out to be krt. This is what we'll get. Since we got v as the dependent upon time, it is not independent of time, so there will be a acceleration tangential or the tangential acceleration, and that will be equals to dv by dt. So it will comes out to be kr. Hence what we can say that the force tangential will be equals to ma. Force tangential will be equals to ma tangential, or therefore we can write this as force equals to m a tangential, and substitute the value of a tangential, that is m kr. So this we got this as the force mkr. Now power, we know that power is equals to force F dot V, that is this is the tangential force and this is the velocity along the tangent. So this will straight away comes out to be FV. So it will be mkr. Now what is V? It is, we have found it out, V as krt, so it will be into krt. So therefore we can write this as m k square r square t, and this is the power delivered. This will be the answer. Let's look at the options. So according to the option B should be correct. Now let's check it out, the next question. Now the masses of 1 gram, 4 gram are moving. The masses of 1 gram and 4 gram are moving with equal kinetic energies. Kinetic energies for these masses are equal. That we have to find out the ratio of magnitude of their momentum. Now what we have, we know that the momentum is equals to mv, or else we can write this as p square, that is momentum square. We can write this as m square v square. So therefore this we can write it as half m square v square p square by 2. So therefore we can write this as p square by 2m is equals to half m v square, and the kinetic energy, let's take it as k. Now Now, because kinetic energies are given to us are as equal, so we are finding it out what is the momentum in terms of kinetic energy. So therefore, what we can write, P will comes out to be 2mk under root. So therefore, since the masses are given to us as m1 is equals to 4 grams, m1 is equals to 1 gram, and m2 is equals to 4 grams. So m1 by m2 will comes out to be 1 by 4, and p1 p is equals to, we got the relation as 2mk, so p1 by p2 will comes out to be under root 2m1k, let's say k1, and 2m2 k2, since it is given that k1 is equals to k2 is equals to k, because in the question it is given that they have the equal kinetic energies, so k1 will be equals to k2 will be equals to k. So therefore what we left with under root m1 by m2, so hence it will be under root 1 by 4 and hence 1 by 2. So if we check it out the option, it is p1 by p2 is equals to 1 by 2 we are getting. So if we check out the exam question options, what is the option? C should be correct then. Now let's check it out what is the next question. Now in the next question, the ideal spring with spring constant K is hung from the ceiling and a block of mass capital M is attached to its lower end, something like this. You have this, your mass is attached. The mass is released with the spring initially unstretched. Now mass is released, as mass is released, so therefore speed of the mass will be 0 at this moment. Now the maximum extension in the spring. Now at the point, let's say at the maximum extension, let's say it goes to this point, and this is the maximum extension. At the maximum extension also, V will also be 0. Momentarily it will be at 0, and after that it will try to come back or come in the opposite direction. So therefore if we say that this is the maximum extension, let's consider that this is x. So now from the work energy theorem, we know that the work done net is equals to change in kinetic energy. Since initially V is also 0, finally also V is 0, so change in kinetic energy will be 0. So what we can say that the work done net will be equal to 0. So work done net will be, so if we look at the complete system, there are two forces, that is the gravity force and the spring force. So what we can say that the work done by gravity plus work done by the spring, this will comes out to be equal to 0. Now let's check it out what we are getting, the work done by gravity and work done by spring. Since we know that the work done by gravity, mg, as mg is acting in the downward direction for the block, and displacement is also in the downward direction, so work done by gravity will simply comes out to be mgx. But what about the spring force? Since we know that the spring force initially it was this, we have done already that spring force is equals to minus half k x final square minus x initial square. This we have done. Now I know that the x final is equals to x and x initial is equals to 0. So what I'll get this as minus half k x square. So if we write it down in the equation that the work done by the gravity plus work done by the spring is equals to 0. So therefore what we will get this mg x plus minus half kx square, so this will be equal to 0. So what we can write this as mgx is equals to half kx square. So therefore what we will get, x will comes out to be mg by 2mg by k. This is what we will get x. So therefore, if we check out the options, then option B should be correct, 2mg by k. Now guys, let's check it out the next question. The next question is, a bob of mass this m is suspended by a massless string of length l. This is given. The horizontal velocity v is at position a is just sufficient to make it reach the point b. This is point b is given. The angle theta at which the speed of the bob is half of that at a. So that this is the angle they are asking, this angle theta they are asking, and here it is v by 2. The speed is v by 2. So now if we talk about this point a and point b, v is, first of all we have to find out what should be the v so that it reaches at point b. So if we talk about only point a and point b, so what we can say that at point b, now we have the formula that at point B tension is equals to 0. So if we talk about the tension, we have the formula T is equals to mu square divided by R plus 3mg cos theta minus 2mg. Since we are talking about this theta, since we are talking about this and point A and point B, so theta will be 180 degree after bob reaches the point B. So theta will be 180 degree, tension will be 0, and R here is RL. R is L actually according to this situation, and U is the speed at point A. So it will be V. So if we substitute this thing, we will get what we will get. We will get this as mv square divided by L equal to 0 minus 3mg. This will comes out to minus 3mg because cos 180 will be minus 1 minus 2mg. So therefore what we will going to get? We will going to get v square is equals to 5gl, or else v is equals to under root 5gl. This is what we will going to get the speed. So this is the speed such that it just reaches to point B. Now what we have next? Now now we have to find out this angle theta, as we have to find out angle this theta. Now let's consider that this point is point C. Now as there is no non-conservative force, so what we can say that the energy at point A will be equals to energy at point C. This is what we know. Now if we consider that this is the point A is on the reference level, that this is, so if point A is on the reference level, then the potential energy at this point will be 0. So therefore what we can write, so point A will only have the kinetic energy, since potential energy is 0, so it will be half mVA square, and VA is given to us as V. Now at point C, now they are saying that the velocity at point C should be v by 2, so it will be half m v by 2 square. Now we have to check it out that what should be the potential energy. We know that the potential energy is mgh, and we have to find out h, this h. Now if we look at the figure, so h should be this much should be h, and this we have done. H is equals to this, h will comes out to be L1 minus cos theta. So therefore if we substitute it over there, what we're going to get, this will going to get as m and m will going to get cancel out from everywhere. So this we're going to get v square minus v square divided by 2 is equals to 2gh, and let's substitute the value of h. So this will be 2g L1 minus cos theta. So therefore v is equals to, we got this as under root 5gl, and after substituting what we're going to get this as, instead this will not be v square by 2, this will be v square by 4. So this we're going to get 5gl minus 5gl divided by 4 is equals to 2gl minus 2gl cos theta. So what we're going to get, gl and gl will going to get cancel out. We're going to get 5 minus 5 by 4 minus 2 is equals to minus 2 cos theta. So if we take it, so this will comes out to be 20 minus 5 minus 8. So this will comes out to be divided by 4. So it will be minus 2 cos theta, and hence we will going to get this as 7 by 4 minus 2 cos theta. This. So therefore cos theta will comes out to be minus 7 by 8, and hence theta will comes out to be cos inverse minus 7 by 8, and this nearly comes out to be 151 degrees. Now if we look at the option, so option A cannot be there because pi by 4. So the limits are from, according to the option D should be the correct. So therefore option D is correct for this question. Now let's move to next question. A block of mass 2 kgs is free to move along x-axis. It is at rest, and from t equal to 0 onwards it is subjected to a time dependent force Ft. This is given to us in the x direction. Okay, so the force Ft varies with F as shown in figure. Now the kinetic energy of the block after 4 seconds. Now since Ft graph is given to us, so we know that force is equals to change in momentum, like this rate change of momentum. So what we got, the momentum will be equals to, change in momentum will be equals to F dt. So from here, as we have seen that we got this as work done is equals to F dx, and we said that the area under the Fx graph is the work done. So if we look at the expression, this is similar to this expression. Now from this we can say that the area under the Ft graph will only going to give the momentum. So therefore what we will going to get, momentum area under this complete curve will going to give the momentum, complete momentum. Now in the question they are asking about the kinetic energy. How can we find out the kinetic energy if we have the momentum? If we look at the thing that momentum is equal to mass into velocity, or if we talk about the magnitude, it is the mass into speed. So let's consider its mass into velocity. Now if we square this thing, this will comes out to be m square v square. Now if we want to find it out half mv square, this will comes out to be p square by 2m. So hence if we write this as the k, that is the kinetic energy, the kinetic energy is p square by 2m, and hence we can write this as k is equals to p square by 2m. If we'll be able to find out the area, if we'll be able to find out the momentum, we'll be able to find out the kinetic energy. Therefore let's find it out the area, that what exactly P is. So P is the area under the curve, area under Ft. So therefore let's find it out what exactly we are getting the area. So if we talk about this thing, this area will be 4. This area is the area of the triangle. That means this area will be the 4 into 3 divided by 2, half base into height. Now if you want to find out the total momentum, so it will be this will comes out to be positive and this will comes out to be negative. So this will be minus 3. This distance is 1.5. So this 1.5 into 2, because this is given to us as 2. Sorry, this is misplaced actually. This is given to as minus 2. So this will be 1.5 into 2. So therefore this will comes out to be 2, 6 minus 3. 6 minus this will be divided by 2 again. 1.5 into 2 divided by 2. So this will comes out to be 3 by 2. So therefore this will be 6 minus 3 by 2, and it will comes out to be 9 by 2. Momentum, this is the momentum, total momentum. So as we have to find out the kinetic energy, let's substitute the value of P over here. This will comes out to be 9 by 2. So 9 square divided by 4 into 2 into mass. Mass is given to us as 2 kgs. So therefore let's substitute the value of 2 over here also. So this will comes out to be 81 divided by 16. Now 16. So this will comes out to be nearly equals to 5.06 something. So this is the approximate result. So let's check it out the options. So therefore this only option C should be correct. So guys, if you have any query, so you can log on to our website www.askIITians.com, and here you will going to find many options, and here you have to choose. Among that options you have to choose ask a question, and upon clicking on that you will going to see a discussion board, and on the right hand side you will going to see an ask expert. Here you have to select a category. Like if you want to select a category in the physics like general physics, so you have to select general physics. Now here you have the text box, there you can write anything to get answer from the expert. And you can also attach image by clicking on the link attach image, and after that you have to click on get answer to get answer from the expert, and we experts will going to revert back in 24 to 48 hours. Okay, so guys, we came to an end to this chapter. So in the last part we have done IIT JEE previous year questions, and if we recall that what we have done, so most important things I'll going to recall. That is that we have done the work, and the next important thing after that is the work done by the variable force. That is a very important thing. After that, the work energy theorem is very important thing, that how can we relate work with the change in kinetic energy. That was we have done in the work energy theorem. And after that we have the conservative force, and next to that is the conservation of mechanical energy. That conservation of mechanical energy is that only when we have the conservative forces. Now after that we have the power. The last topic of that work energy power is the power, and we have already done that. So these are the important things which we are pointing it out. So for this chapter we have to take care of these points. So for the more videos for physics, chemistry and mathematics, stay tuned with Ask IITians.